kid that I didn't even care what month it was. I knew my birthday, and that was about it. Christmas, August. Yeah. Okay. Vertical, horizontal, right? Now, if somebody gives you a line that is not vertical or horizontal, we can start talking about some characteristics. So properties of lines not vertical or horizontal. So I'm only talking about lines right now that are not vertical or horizontal. If you draw a line that's not vertical or horizontal, it's got to be one of these two cases. It's either got to have a pitch to it that's like this, or it's got to have a pitch that's more like this. So as you know how when we read books, we read left to right? Yes, I did do that correct as a kid. Left to right is the way we read books. If you were to be moving from left to right here, you would actually be going up, wouldn't you? And then here you'd be going down. So with this case, we say that this line has a positive slope. And here we say this line has a negative slope. How are we doing on time? 15 minutes? Okay. Positive slope, negative slope. Now I said this is the situation when we have lines that are not horizontal or vertical. Let's talk about it real quick though. How about a vertical line? What do you think we can say about that slope? What do we call it? And then what about a horizontal line? What do you think we call its slope? I heard undefined. That is correct, but which one of those? The vertical line has what we call an undefined slope. What about the horizontal line? It's got a zero slope. So think about it this way. If this is positive and that's negative, then how do you get from positive numbers to negative numbers? You have to go through zero, don't you? You have to go from positive to zero, then to negative numbers. So it kind of makes sense that a horizontal line would have a slope of zero. Slope is equal to zero. And then for vertical, the slope is undefined. That just means that we have, if somebody says, hey, you know, what's the slope of vertical line? All you can say is, look, vertical lines don't have slopes. All right, so I don't know what you're talking about. It's not possible for me to discuss slopes of vertical lines. I know this is still a lot of review here. Let's see if we can play a game in 1 minute while I'm writing this up here. Anybody who has a birthday in January, raise your hand. January birthdays? No? Okay. How about February? Okay. Say the day, the numerical day that your birthday's on.
5.
Any other February? Okay. March? Start saying, just two? What's your dates?
11. 14.
Okay. April? May? Wow. June? Okay, June what?
26th.
10th?
23rd.
23rd? 11th. Okay. July? July 7th?
23rd.
14? 19. Where are we? August? Right? 31st?
28.
Okay. September? 25th. 30th? 28th? 22? 12. No matches yet. September. October?
30.
30? 3rd.
29.
29? 21. November. December. Just you, huh? Okay, that didn't work out well. Well, I didn't expect it. Do you think it would have been very like crazy if two people had the same birthday? No? Yes. So does it seem improbable to you that two people would share the same birthday in here? It's actually, well, hold on. Sir, when's your birthday?
May 31st.
No? 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 Okay. All right. So it turns out that in a room of 28 people,
What do you say? March 14? Yeah. You? Yeah, me.
same?
Yeah.
Where? March 14th? Same birthdays. All right, it happened. Good. We're going to check your IDs afterward. No. No. So in a room of 28 people, the probability that two people share the same birthday is a coin flip. It's 50-50. So it's not that unlikely that that happened. It was a coin flip. That seems weird though, right? That it is that way, but that is the way it is. Okay, special forms of lines. So I gave you the standard form of a line, didn't I? AX plus BY equals C. But there are some other special forms, and the one that we love to use is what we call the slope-intercept form. The slope-intercept form. And the reason why it's called the slope-intercept is because when you look at the equation, you can identify the slope and the y-intercept just by looking at it. So here's what it has to look like. And you've seen this. Y equals mx plus b. So the m is the slope, which we define to be the rise of the line divided by the run of the line. So rise is the up and down, and the run is the left and right. And then the b is the y-intercept. In other words, it's this point on our graph. It gives us that point on the y-axis. Now, what I want you to understand right now is that the difference between slope-intercept form and standard form is very simple. The only difference between the two forms is that this one is solved for y. That's what makes slope-intercept form slope-intercept form. You take the standard form, solve it for y. So let's go back to that example. The first one I asked us to graph. I believe this was it. Do you remember that one right there? We graphed that one a little while ago. We did that by, first we did it by just picking random points. Like I asked people to give me some solutions. Then we actually did the x and y intercepts, right? And now what we're going to do is, even though we could graph it with x and y intercepts, we're going to turn it into this form first. So that means I'm going to take that equation and solve for y. So let's do it. How would I solve for y? How would I get y by itself here? First, take 3x to the other side. So negative 6y equals negative 3x plus 18. Notice that when I wrote this, I did not write 18 minus 3x. Right? I put negative 3x plus 18. I did that because I'm going to try and make it look like this, right? And the x term comes first, then your number. So that's the only reason I put that this in front of the 18. I have one more thing I need to do. What is that? Divide by both sides by negative 6. So divide by negative 6, divide by negative 6, divide by negative 6, and you get y equals, what's this right here? 1/2, right? Now, when you write this 1/2, you could write it this way, but I'm not going to. We want to get away from this sort of notation. We instead want to write it like this. 1/2 times x, like that. That's the way we'd like to write that. And then over here, 18 divided by negative 6, minus 3. This is now in slope-intercept form, isn't it? Looks like this, y equals mx plus b. Now, what is the usefulness of the slope-intercept form? Why is the slope-intercept form useful? To graph. It's easy to graph using that. So let's do that real quick. We're going to graph this. So where do you start when you're going to use this form to graph? What's the first thing you identify? The -3, your y-intercept. You start there. So -3 on the y-axis. 1, 2, 3. You put a dot there, -3. And then what do you use? You use this m, the slope, the 1/2. And this tells you right here that you're going to go up 1, and down here it says you're going to go to the right by 2, right? What if this had been -1? You go down 1 and then to the right 2. So where do I start out? I'm going to go up 1 to the right 2. Do I start at the origin, go up 1, right 2? No. I have to start at this point. From this point, up 1 to the right 2. So up 1, right 2, and put a dot there. That was just showing you where I was. 1, 2. So up 1, right 2. Once I have 2 points, I'm good, right? I can draw a line? What was the x-intercept of this? We did that earlier. What was the x-intercept? It was, yep, 6. It was 6, right? If I were to actually go out here 3, 4, 5, 6, I would hit at 6. If I draw my line real good, it should go through that point. So slope-intercept form is very convenient for graphing. A lot of times, like from here on out, we're going to be working with them when they're already given to us in this form. So we just graph. There's another form of a line. Oh, we're almost, well, you know what? We'll call it. 3 minutes. I don't have time to get into the next one. Everybody do this. Okay? And then your homework for tonight, or for the weekend, is from 1.2, but don't do the whole assignment, because I haven't talked about everything yet. Let me just look at these real quick. Sketch the graph. 49.
Do you have the paper?
Yes, hold on. It's on the back of this one. On the homework for 1.2, stop at 27. And we'll pick up next time at that point. Okay, just initial. Don't worry about the numbers there, just initial. All right, everyone, have a great weekend. Football starts this weekend, right?